Most robotics demos never ship. Deployed is about the ones that do. This is Deployed, where physical AI gets real. So, super excited today to be talking to Jeff Wilke, who's been a long time, role model, peer, executive leader, manager, advisor, investor, kind of every...
And admirer of Brad Porter.
Well, thank you. But really wanted to go back a little bit. So, a little bit of your career arc, right? You started in manufacturing, and then you brought a lot of that capability 22 years at Amazon, but then really saw the transformation coming way before everyone else did as to why it was so imperative the U.S. bring back manufacturing. And so give us a bit of that arc and that context, and then we're going to go deeper in a few of those areas, but really wanted you to kind of set the frame.
Sure. Well, again, Brad, it's awesome to be with you. I've enjoyed our conversations for 15 years together, and this one's going to be no different. I'm sure it's going to be wide ranging. You have a huge array of interests, so I woke up thinking about what could Brad ask me today, and there's no way I'm going to guess. So I grew up in Pittsburgh, and I grew up in Pittsburgh in the 70s, and I watched the steel mills rust. And more importantly, I think I watched the impact that the degradation of industry had on the communities that were around me. People lost their job, parents lost their jobs, kids and families were impacted. Unemployment was very high in the area. Other than the Pittsburgh Steelers and one great season of the Pittsburgh Pirates, there wasn't a lot of hope. And I think that kind of story played out across the U.S. over 30 or 40 years, where we were optimizing for relatively short-term financials. It was harder and harder to, convince investors to support long-term investments in property, plant, and equipment, sort of capital investments. It was easy to find partners in Asia and elsewhere who were willing to do things at much lower cost, and then eventually include engineering and design, so that, all you had to worry about was a brand and a market, and everything else would be taken care of. And that seems like a very thin layer of expertise and core competence, for companies and ultimately for industries. And I think what's played out is that we've just hollowed out these really important core capabilities that allow us to make the things that we depend on for wellness, for energy, for transportation, for entertainment. And it makes the society and ultimately democracy more brittle. And growing up in Pittsburgh cemented to me the importance of having a robust industrial economy. And I spent a couple years as a software developer as a bit of a detour. And then I just started reading all this stuff in the late 80s about the decline of American productivity and the impact that would have on the wealth per capita, basically the resources for our society. And I decided to go back to school to study manufacturing and work there for 6 years. And then Amazon called, and I did a little detour myself.
Yeah, let's go a little deeper in that kind of Amazon history. So I think Jeff Bezos tells this famous story about how in packing books he thought they should get knee pads, and some engineers said maybe we should get desks, which he thought was a brilliant idea. So how much beyond desks packing books was it when you arrived? And then you obviously brought you brought a transformation vision to Amazon of how you thought logistics really could work. And so tell me a little bit of that story.
Well, look, a couple of things. The company had a bunch of the raw capability that was going to turn out to be really important, beginning with software. So the idea that all these physical processes have some instantiation or twin in the digital world was present even back then in the architecture that Amazon was building, and it had very competent computer scientists compared to most people in the physical world. What it didn't have was a point of view that would match the ultimate sort of factory physics, the challenge of moving all these things through a warehouse, especially at peak times like Christmas. And that's something I happen to have by accident because of my focus on manufacturing and the work that I had done for 6 years in the chemical, metals, electronic components industries. I learned a ton about how you manage bottlenecks, how you sequence work to get the most out of your whatever your most capital intensive bottleneck piece of equipment is. I learned a lot about ways that you can improve quality and lower costs at the same time, including things like statistical process control, and even Six Sigma was popular at the time. But ways to look at variation and characterize it and reduce it. And these things were, and also the how to run a complex plant that's more complex than a plant that simply has, and I say simply with no disrespect to people who operate complex warehouses, but when you're moving pallets around with fork trucks or maybe cobots, it's a simpler challenge than when you're assembling orders from multiple items, maybe millions of items, and you have a very short time to get the first and the last item into a slot or a box before you plug up the entire system with half completed orders, which was really the challenge that they had at peak. And I just walked in with a set of tools that had been honed over decades by really, really smart people working at places like Toyota. And we didn't have time for me to do first principles redesign of this whole thing. I had a playbook. My instincts were that it would work. And we were very fortunate that the principles scaled from $1 billion to, now, essentially $1 trillion going through the network.
I want to get back to some of that kind of innovation in the network and how you think about that, and then ultimately more to kind of rebuilding what you're doing now. But I want to stay in some of this early Amazon lore as well. I think Jeff Bezos not too long ago told a story on stage crediting you for coming into him and saying, Jeff, the number of ideas you're producing could destroy the company. I think we have a lot of founders who are tuning into this. I think they're interested, at the same time, Alfred Lin sent out something to kind of Sequoia portfolio, pointing out that you have to be kind of scanning for opportunities and maybe be willing to position your company to get lucky with new opportunities or to seize new opportunities. And so, how did, I'm sure there's much more to that story with Jeff. Like, how did you guys find the right balance between exploring and then focusing on, exploiting the opportunity that you had in front of you?
Yeah, I mean, this is the balance is the key word, and actually, a better word might be tension. You want these to be in tension, not necessarily balance. Maybe implies too much comfort. So the first thing is, my brain tends to think in terms of process in most of the things that I encounter in the world. So I think about, flow maps, topography, and how things move together, and sort of systems dynamics of how those movements occur. And so anytime I encountered a bottleneck, whether it was in a plant, in software, or in an organizational design, I would apply the same kind of thinking, which is, how do you maximize the use of the bottleneck and prepare everything else to be subservient, basically, to whatever you've chosen to be the bottleneck. And by the way, one of the principles that you and I talked about a lot in the early days is that I think you have an operating plan when you choose the bottleneck, when you decide where you want the bottleneck to be. If the bottleneck reveals itself to you like in a surprise, month after month, quarter after quarter, year after year, you don't really have an operating plan. You have a reaction plan. And those two things are pretty different. So I found myself, focusing more and more on the bottlenecks of the company after we, started to make progress in improving the plants. And it was very clear that Jeff was an idea machine. Like, which is what you want. And I think Alfred is correct that you want to have people, especially if you're fortunate enough to have them at the top of the company, who are generating really great ideas. Now, there are people that generate a lot of ideas, and most of them are terrible. In Jeff's case, he generates a lot of ideas, and a lot of them are really good. And his brain is constantly working on, sort of innovating around challenges in the world. And I loved having that stream, but I watched the stream get it would hit the button. So it hits the bottleneck of the company's ability to implement any of it. And it's stuff flying all over the floor, because basically what happens is when the org starts to drown, it builds a shield. And then the ideas just hit the shield and just scatter all over the place. And nothing gets through. So what I think that comment did for Jeff, and later in that little thing that a couple of people sent me, and I sort of listened to what he said, he's correct. He identifies the other part of the conversation I think is even more important, which is you could say, well, I have to slow down the pace of ideas. That would be one approach for Jeff to have taken. But fortunately, Jeff didn't take that approach. He said, well, what do we need to do to relieve the bottleneck so that we can process all these ideas? And what do we need to do organizationally? What systems do we need to build? What constraints do we need to put in place? And we worked on that for years together and with the S team to figure out how to organize mechanisms and and a human hierarchy so that it could absorb many more ideas. And I think that the trick is a great operator is always going to be in tension with a great innovator. Now, very occasionally they're in the same person, but there's almost nobody I've ever met who is world-class at both. And the trick is that the operator, while they're going to feel like the innovator is throwing too many things at them, the operator has to catch enough of them to be better than the competition. And the innovator has to have enough awareness to not drown the operators who are doing things that are way more complex and hard than they appear to be when you're an innovator. And this is one of the asymmetries of this kind of stuff is that, operators generally know how hard it is to innovate. They might poo-poo it sometimes, but they actually know they're not great at it. Sometimes innovators gloss over the hard details of operating that make it really hard to instantiate these things in the real world. And so hopefully you get that tension at exactly the right strength and force so that you build an amazing company.
So I joined your organization, I think in about 2014. And it's about the time that Amazon unleashed one of its boldest ideas on 60 Minutes with the drone program. Give us as much as you're willing to kind of the backstory of how that came about, because I don't think it's told very much. Everyone just assumes it's like Amazon working backward, but like there's a little bit more to it, I think.
Well, one thing that's really cool is I just happened to check in with the team a week ago or so, and it sounds like they're making real progress. Lots of deliveries are happening, so you probably have a lot more information than I do. But
I keep up with those folks as well. Yeah, no, it's
taken a long
amazing.
time, but it is super cool. So that's one of those things where a person, Kimchi, came to me in 2013 and said, "Hey, somebody's going to build a drone delivery system because we now have basically the onboard compute that's fast enough." I mean, that's what kind of we were waiting for, right? If you're not going to fly a dumb bird, you want something that probably has some sense and avoid capabilities. You want something that has autonomous flight control on the vehicle in case it loses coordination. You have to have enough compute, and that compute has to be light enough. And it kind of took into the 2010 timeframe before, maybe a little bit before that, but before we could actually think about doing this at a reasonable cost. And he saw it and he said, "I think we could do it. I think we could build a drone system for delivery. We can't use a quadcopter. That we could start with a quadcopter, but we're going to have to probably build something that's a little bit more complicated than that. And eventually it's very clear that we needed to have wings of some kind, or it's just really inefficient." But he was already thinking about all this stuff. And he said, "Will you fund it?" And I said, "Well, this is Amazon. The way that we think about new ideas is we write a press release and working backward documents, and we try to imagine the product at the time of launch and encode all of that in the working backward documents." And so he wrote a document about the experience that we might envision, and we did then some cost analysis to say, is it even feasible that we could do this? And to my surprise, it looked feasible. And feasible means that you could imagine a trajectory where the cost of a delivery by drone would be less than the cost of a delivery by truck. And it didn't require fundamental science to get there. So, next step was to kind of fund a team. And I didn't talk to Jeff. I didn't ask the CFO. I just funded it. And Gur hired a group of people to get started on work. And they worked in one of the guys' garage for a couple months to put together a drone and prove, kind of proof of concept. And then Jeff and I were having a conversation at an ST meeting, and he said, I've been thinking a lot about drone delivery. People had started to speculate about it, but nobody had come out with anything. He said, I actually think, this is going to matter for us in the long run, and we should get started. And then I said, well, turns out there's this very small team that's been working on this, and they've made a lot of progress. Just way more to go, but we have some idea kind of what it might take. And he said, well, I think he said, can we get something flying and have a video in like, I don't know, 6 weeks or something, or like a month. I mean, if we had started from nothing, there'd have been no chance. But we were far enough along that we were able to put together the background and the experience that was featured in 60 Minutes, and the rest is history.
Oh, that's awesome.
Your contribution to that was really an opportunity for us to work very closely together on an operating thing. We had done a lot of architectural work together on the software side, but this was like a different kind of experience for us. And your maturity, your understanding of both the physical instantiation of these algorithms and capabilities, and then the software side that was going to be necessary to orchestrate them, was incredibly valuable for that team. And you're a great recruiter of talent too, so you brought a lot of great people to that. I think it's still, I'd run people who have that on their LinkedIn, and there's an amazing team of graduates of the primary program.
No, I'm super proud of the team we built. In fact, I took the recruiter I worked with there and brought her in as employee number 4 at Cobot. So she's built the team here as well. And
Brad, if I think about that, if there's one thing that I wish we had been able to move faster, and that's on me. There's this tension. This is another time. There's tension between getting the design to be, right. And when we ultimately got to that design that had the foil for lift and a much kind of simpler approach to, meaning no need to actually move the angle of propulsion. You could do all that with software control. Then we had a machine that I knew would scale. But I think we were slower than we should have been.
It's fascinating because I took a lot of lessons from that. I think because the first time I was really integrating hardware, software, and AI, right, and in operations, and it's obviously a systems discipline, right, to bring all of that together. And I think one of the lessons I learned from that was that when you're trying to bring the whole system architecture together, more brains don't actually help you. You need vertical, you need like these T-shaped people who have kind of broad systems breadth and vertical depth, and you need maybe a dozen of them, right, who can kind of cover each of the different functions from aerodynamics to to the AI. But we did get that team pretty big fairly quickly, and now when I move over to robotics and even of Cobot, when we're doing that early systems work, I actually try to keep the number of folks smaller, to really iterate really fast on the system. And then once you get the system, then you can explode it. And so I think we almost went too fast early, which caused us to go a little slower in the middle.
I think you're right. I also think, and I think about this a lot now, when I think about org design for small new things and even for established things, I always ask designers to think about 2 main principles related to how humans and machines work together. And one is, for every team, I think you have to ask the question. So if you're running an established business and you have teams that are not using AI for much workflow, first question is, what is the agent that would enhance the capability of each team fastest and in a most powerful way? And build that agent, in a week or less. And I think what we would have done is said, we don't need as many human engineers. What we need is amazing human engineers. And then at least one amazing agent that's a machine that specializes in each area where we have a human team. And that would have allowed us to, I think, scale faster without having to add as many people, which just introduces management challenge. And then the other thing, of course, is that every manager, I think, we should think of them as a hybrid manager, meaning in every management job on a box, there's a human and a machine sort of complement to that human that makes the human manager way more effective and allows them to have larger span of control, a flatter organization, move faster, and so on.
I think it's so. Uh, and yeah, it's tricky to bring hierarchy in too early when you're building a system. On the other hand, you need that kind of like lead engineer, chief engineer, whatever, to help kind of. I do remember, yeah, we started to go a lot faster when we started to build the simulation tools and the AI tools to look at different morphologies of drone, because that ultimately was the key to getting the kind of range and performance, and you needed that range to make the economics work. And well, let me fast forward a little bit. So, and I'm going to tell the story as I remember it, but then I'm kind of curious your take
Uh-oh.
of the story.
Uh-oh. It's
Um,
amazing. Plus, it's not only is it a different perspective, but there's so much time, which I'm finding more and more that time really distorts stories. But please, let me
yeah.
let me hear.
So here's what I remember. So I remember sometime in I think it was either late 2016 or early 2017. I think it was maybe like January 2017 is what I'm remembering. I remember a meeting with your leadership team that you called, and you had asked your finance and economists to build a long range forecast, to build kind of a 10-year forecast. And what I recall is that forecast said by 2021, Amazon would have 1 million employees. And as I recall, it was about 200,000 at the time, and we weren't sure how we were going to scale. And I just remember like the whole room not believing it, right? I remember everyone being like, the data must be wrong, right? How are we going to have 1 million employees? And then I remember the obvious takeaway was, are there even 1 million people who want to work for Amazon, right? And how could that even be possible? And therefore, how do we bring automation online faster? And that was kind of like my first like peak of like, oh, this could be a meaty enough problem to get really excited about for myself. But I'm curious. There's probably a little bit more backstory. There's probably a little bit, maybe I don't know if you were trying to set up that like inspiration light bulb for folks, or if that was kind of organic. Like, I'm curious if maybe even if you remember that whole meeting.
I do. In fact, it's this visioning thing that over the years I've tried to use as a way to think about preparing for scale. And it's just like, it's very simply, compound out growth in whatever is the core measurement of the thing that you're working on, and get it compound it to the point where it's substantial enough that it causes that kind of a reaction. And then ask some questions like, is there enough capacity in the world? You mentioned, are there enough people that might want to work at Amazon? It turns out there were. You have great benefits and you created a nice environment, and in places where the alternative is a much worse job, like you can get lots of great people to be excited about working there. But what else might limit you? And it could be physics, it could be engineering capability. And it turned out I just started asking like, and this started in 2014, 15, but I worked on this with Melissa Emer, who was my technical advisor at the time. And we just started saying, so are there enough cardboard boxes at the scale we're going to be? Turns out there was plenty of cardboard. Is there enough steel for shelving? Yes. Are there enough places where you can put warehouses? Yes. One of the interesting things was, is there enough capacity in the U.S. delivery system? The answer was no. So there were 2 or 3 things that came out of that analysis that changed my view of our strategy. One was we had to build a much more significant transportation capability, or we were going to run into the slower than necessary pace of deployment of capital by the incumbent players in the industry. That's why Amazon built, its air fleet. That's why it does, you get deliveries by Amazon drivers. I mean, all the stuff that I think Dave Clark drove brilliantly to scale came from that analysis, which was like, wow, we are gonna, we're not choosing our bottleneck. If we let things play out, the incumbent transportation carriers will create a bottleneck for us, which is unacceptable. And so we have to choose the bottleneck, and we're going to choose to vertically integrate into transportation, because otherwise we can't support customers. And we made that choice, and I was super proud of the way the team executed there. But the other one was management. And one of the conclusions that I reached from this thing is, if we're going to be 1 million people, we're going to have roughly like 10,000 managers in the retail part of the company managing the whole thing. And at the time, we had between 1,000 and 10,000. It was probably like 6 or 7,000 or something. But you could see it growing to 10, and then who knows from there. And I started to ask the question, which you'll remember, of my team regularly, which is, why would we ever need more than 10,000 managers at any scale to operate this thing? This thing being, a retailer. And my conclusion was, we have to invent a way to not need more than 10,000 managers, and maybe need less, so that humans can work on other things than simply exchanging ideas that already exist from one person to another and compressing. I mean, if you wrote down the things that management bureaucracies are great at, that it tends to be like memory, compression, certain kinds of computation. These are all things that LLMs got really good at. But in 2017 or 18, I wasn't smart enough to read the Transformer paper when it came out and then leap to, okay, the singularity or whatever is actually getting closer. I was just saying to the team, if I just look at first principles, we're going to hit a bottleneck that is management, and we're going to have to reinvent management science if we're going to continue to grow. And now we know what that reinvention is. It's learning how to work alongside machines, so that we don't end up with, bureaucracy that overtakes everything.
So not too long after that meeting, I remember Dave Clark kind of assigned a goal against himself to hire a robotics leader, because you said there were kind of 3 big bottlenecks: the transportation, management, and automation.
Yeah.
And I remember coming to you and saying, "Hey, I might be interested in that." But I'm curious. I mean, you have a kind of a way of looking at talent that's a little bit different, and I'll admit, like, I was a distinguished engineer at Amazon. I had a lot of credibility and authority, but my background was large scale distributed systems, the e-commerce platform architecture, the migrating the company off of Oracle databases. Like, that was kind of my like wheelhouse. And so I'm curious, like, what, because I'll admit, like, you go into those meetings, if you're interested in a job, you put all the imposter syndrome aside, right? And just raise your hand and say, I think I can do this. But meanwhile, like, I'm certainly sitting here being like, I haven't been in the operations side of the house. I'm curious, like, again, from your side of the story, when I came into your office, like, how did you look at that? What were you seeing maybe in me that would give you the confidence I might be able to tackle this? Yeah, I'm curious, kind of the other side of that conversation.
Well, what I try to do is understand the mental models of the most talented people in an organization that I'm responsible for, and then think about how, because those mental models, when they're rare, are really a superpower. And then what mental model is likely to have the most impact for a particular problem with particular resources. And in this case, I'll talk about you. I mean, if I describe your superpower, which I wrote to you on multiple reviews, I think you have the ability to build the best mental model of an architecture, of a complex architecture, and especially to rotate that model around and aim your attention at whatever thing needs focus without losing the context of the things that are around it. A lot of people can kind of spin up on something, navigate to a place, work on, that part of the topography, and then, the topology, and then work on another part of it, because this is kind of like, imagine that we have a graphical representation, and then work on another part of it. But they can't remember enough about the connections between the pieces of the topology to optimize it in the way that you can. And I always like, that's why I thought you were a great sort of chief architect with me as we were thinking about moving from the old systems to a native AWS system. And in this case, it was the same kind of thing. I thought that the problems would not be, let's call it the atomization of the automation. So, instantiated in some kind of robot. I actually thought our largest challenges would likely be orchestration, and we were going to need both. We were going to need the clever ability to, disaggregate work and then reaggregate it in different forms, preferably less complex than the forms that they replaced, and more flexible, more precise, flexible, fast, lower cost, and then have an orchestration layer on top. And you were the only person in the company that I thought could do that with a partner like Dave, who has a different way of looking at the world, a different kind of communication style. But the two of you together, I thought, would be a really powerful team. And as you recall, I counseled you that there would be times when you drove each other nuts, and I would ask you to just listen, because the insights you'd get from Dave would be pretty remarkable. And I asked him to do the same thing, and I told both of you guys, if you really can't agree, come find me. We'll go to lunch and figure it out.
No, I think that ended up being really, obviously, super productive partnership. And I think Dave's ability to kind of see both the network level process flows, but also just what was really going to work in moving. Hopefully we'll get him on one of these as well.
I'm sure you will.
I do the same thing. I think about people's mental models, and maybe even a little more reductionist in that, like, my mental model for you, Jeff, just ended up being like the closed loop feedback diagram. I'm like, just assume that everything going through Jeff's brain is the classic, closed loop feedback diagram. And I would teach as many people as I could in your organization to use that model, and it helped them tremendously to figure out how to communicate with you. And then Dave tells a story where he would help move instruments around for a band in like high school and college. And so he was always just thinking about, like, how am I going to get all this equipment from here to here with the smallest truck and pack it all in? And he just scaled that to like the globe, right? And so that was amazing to work with him for. And then I was able to look at, hey, this system applied to this problem with this software integration, with this AI capability. And I think, another one of my superpowers is like to really understand what's in a short reach of where the technology is right now, right? Like I never like to take on the like impossible problem that's 10 years out. Some people love the like, I'm going to go work on quantum computing or fusion energy, and it's like where there's a whole,
like, those things are going to work, so we need people to be thinking about it.
That's right. But for me, I'm looking for the like, how do I make impact fast, right? And I can do that by solving technology problems. And so I'm looking for that, like, what are the hardest technology problems that I know can be solved fast, right? Because if I can solve them faster than anybody and get them out there. And so robotics was just a tremendous playground for me, right? In that there were a huge number of opportunities to apply. And that's obviously the thesis behind Cobot, was that these type of robots can solve real problems in hospitals and logistics and manufacturing right now. It wasn't a massive leap to go do it, and then they get better. I think this is the other side, looking toward the future, and I do a similar thing of kind of rolling into the future and trying to understand what capabilities are going to come along, and do you get better as those capabilities come along. Coming to automation, though, one of the things we've talked about since we left is that I think both you and I have gotten to see more operations that aren't Amazonian operations since then. And I think we've both been surprised that the level of automation, the level of software control, the level of operational rigor is not at the levels that we kind of expected it might be. And I'm curious if you have a thesis as to why, but also, we're obviously working a lot with customers to try to transform, right? To try to embrace and adopt, how do you do a transformation to automation, digital, physical process. But I'm curious, like, where you see some of those bottlenecks. This is becoming a complicated question, but there's another piece to it that maybe tie in, which is I think one of the things Amazon did really, really well, and I'm curious if this was really intentional or just kind of cultural, was hired operators who were excited about change, because not every operator is excited about change. So anyhow, a meaty question, but I'm curious your take on, like, what's it going to take to bring more automation into kind of the North American supply chain and manufacturing base?
Well, let me start with the last thing you said, which is hiring people that are excited about change, and then what kinds of people like that. I think that's going to be vital. I mean, we are going to be changing existing systems. So the way I think about the sort of physical world right now is of industry is that there are just too many deployed assets. Yes, some costs are sunk, but we cannot, and probably from a financial perspective should not, rebuild absolutely everything in the world with completely new technology. That's just it's not going to be efficient, and we don't have the resources to do it. So we're going to actually have to use some of the things that already exist and improve them over time, alongside things that are new technologies, new robotics, new AI, and this sort of hybrid portfolio, I think, is likely to be the best way for an established firm to proceed. And the people that are going to be most successful at this are the people who are not afraid of change, to your point, and who have enough technical understanding of the process that they can work alongside, a cobot coder, as well as cobot machines, to instantiate the understanding that they have into better and better and better designs for process and ultimately for product. And so it's like, so you got to have people who have really good mental models of the inputs and outputs of the thing that you're using to drive value for your company. And the more technical the understanding in total, not everybody has to be an engineer, but the more technical the understanding in total, the better. If you've outsourced all of your technical thinking, it's going to be way harder for you to make this transition. And so as we've started to build this company, Rebuild Manufacturing, which is at the very beginning, we talked about, my journey back to manufacturing. And the goal is that we want to help ensure that the next generation of important products are made in the US. And this starts with great engineering. It starts with great process and product engineering. When I do a plant tour or run into people who are running manufacturing companies, I'll talk to them about their process, and they usually want to talk about electromechanics. And if they're technical at all, they want to talk about how we sort of move things, make things, transform things, and then they talk about orchestration and software and stuff as like an add-on. And a simple question for them is, who's the most, which I used to ask, now it's a little more complicated the way we're writing code these days, but I would ask, who's the most senior computer scientist in your organization, and to whom do they report? And at Amazon, it was the CEO. At most operating companies, it's somebody who hasn't written code in a long time, who doesn't work for the CEO. And the next easy question is like, so do you have a chief mechanical engineer? Well, of course, we're a car company. I'm like, well, at this point, a car has as much compute on it as it does electromechanical. So why on earth would you not have a senior computer scientist, architect, who's sitting on your senior team alongside your chief engineer, who's almost always a mechanical engineer? And that's kind of the problem. I think you have to, not everybody's going to be able to write the kind of software we wrote at Amazon for orchestration. But I think that the companies that are going to make this jump in light speed to wherever we're going are going to be the ones that are really good at characterizing in an engineering way. So the inputs and outputs and the state. And I'm going to reveal myself thinking about this sort of closed loop control thing, but really understand what is observable and what's controllable about the current state. And then how would I take advantage of AI and robotics to morph from what's honed now to what can be way more flexible, productive, fast, robust, and low cost.
Awesome. Yeah, tell me a little bit more. So you just talked about this kind of hybrid model of building off of what we have. The Rebuild has taken a strategy of bringing together not just engineers but also some of the manufacturing components to kind of start to build products end to end. Give me a little bit more kind of the thought process on it's a non-traditional like venture way to build a business, right? On the other hand, it is a model that other private equity and other places. So give me a little bit the thought process on how you guys approach building the company that way.
Well, the first thing I wanted to do was make sure we weren't constantly fundraising. I wanted to actually be constantly building. So we were fortunate to launch the company in 2021. So we got access to a lot of capital, which was just luck. And we took on a lot of it, including a lot of dilution upfront, which I was totally okay with. And I put my own capital in, and then people that I knew and trusted. And we took a very long duration point of view. I mean, it almost echoes Jeff's letter to the shareholder, Bezos' letter in 1997, where he said, like, if we have a choice between long-term cash flow and quarterly earnings results, we're taking the cash flow every time. And that's the message I gave to the investors was we are not optimizing this thing the way a private equity firm would, where we're buying things, we polish them, we improve them, and then we try to sell them, in a few years. We buy them expecting that we probably won't sell them. Now, if the right thing to do is sell them, of course, we won't be, dumb. But we decided to buy enough capability so that we would have a complete portfolio of engineering talent. So we have electrical engineering, mechanical engineering, material science, chemical engineering, computer science, AI. We actually have a relatively large tech team of computer scientists and AI for our size, and it's a complete set of those capabilities that we built process around, so that people that were in a small standalone company that only were good at mechanical engineering have great connection to a world-class aerospace design company that we have in Denver called Answer Engineering. And together they can build structures that neither of them would have been able to build at arm's length in the past, because, as you know, software is still the only engineering discipline that has hardened APIs. The interfaces between every other engineering discipline are way more squishy. We have PNID diagrams, we have ways to describe interfaces, but they don't have the sort of clarity that software APIs have. And to me, that's why you need collaboration among the other engineering disciplines that the market and arm's length transactions don't actually achieve. So we decided build a complete base of engineering, buy some production plants, because the instantiation of our idea, the success is going to be that we build more plants making things that we need in the future in the United States. One of the reasons that that's such a key mission for me, a way to describe it, I think that plants have this advantage of concentrated capital. They tend to not be all clustered around the population. Like, they're not all in LA and New York. You want to go to places where you have land and you have, highways and stuff. So you end up with plants likely to be dispersed. They're hard to move because you have a lot of heavy things that are expensive in the ground. You can move them, but they're hard to move. And so you have enough time for communities of humans to grow up around those plants. And the most important thing I think we could do for the stability of our democracy is to have, hundreds of communities around the country have plants that they can depend on for, at least a large enough number of years that you can get, from first grade to graduate, kind of thing. You can't guarantee a plant's going to be there for 50 years, but if it can be there long enough, people can have stability and build the kind of communities that we sort of we dream about from the past. And we're not going to recreate the past, but I do think that if we combine all of these capabilities, And Rebuild won't be the only company doing this. We have a real shot in the US of kind of rebuilding the capability to control our own destiny in the things we make.
All right, so lightning round. So 3 questions for each of us. I'll go first, and then Jeff, you shoot one, and we'll go back and forth. So, all right, vibe coding. What are you excited about?
It's my New Year's resolution.
That's awesome. Awesome. Shoot one back at me.
Cobot or humanoid?
Oh man, you stole my second question, but obviously, I'm well on the record of thinking that the thing I've been thinking about lately is that like humanoids are this like least common denominator, right? They are not going to be the best at anything, and so when you build a robot for all the logistics in a hospital, why would you use the least common denominator? Why wouldn't you use a robot that's really suited for that? I get why you won't build 2 or 3 of a robot, but if you can build a few 100,000 robots for hospitals that beat a least common denominator robot, you're going to do that. And so I think humanoids are going to have to compete with some great hardware, and they're just going to lose most of those competitions for many domains, right? There may be some domains where the generic kind of helps, but anyhow, I'm on the record thinking that we're going to have really, really great, capable robots that are that beat human performance on multiple dimensions.
You agree that there are probably going to be humanoid robots and cobots?
I think so, but I think I still struggle to. Okay, so I have a framework for robotics. I think you first of all, you need to be able to do the work, right? You need to be able to perform the process path, right? And second, you need to be able to do that with unit economics and costs that provide a positive ROI. But third, you kind of need to be the best solution at that in that domain, right? And so, I look at like storage systems, obviously, things like Ocado or AutoStore or others. What happens over time is initially they both get a bunch of sales, right? But over time, people start to figure out which one performs better, and the market shifts toward that one, right? And it can take 5 or 6 years. These days, timelines are getting compressed, but it can take 5 or 6 years to figure out which one's the best one. But by the time everyone figures out which one's the best one, then one of those is getting a lot of orders and one of those is getting very few orders. And so, I think, yes, humanoids are going to get used in a whole bunch of places initially. Well, if the AI is good enough and the safety is good enough.
And they're robust enough. I mean, the more sensors and actuators you have on board, the more they can break.
And they need to hit the unit economics where you can actually produce a large number of them. So I think they get outcompeted though in almost every space. I think there are some like entertainment style, like if you're gonna have a robotic bartender, you kind of want them cracking jokes and you want an attractive bartender that looks nice.
Wait,
right?
You tell me cobots don't crack jokes?
Oh, they do. No, they do. They do.
Okay.
But they're like for doctors and nurses and surgeons, not not good bar jokes right now. So tell me, like, drones and robots. We talk about it. Like, is there a big difference? If let's say that it's important to our national security that we be good at drones. Do we? If we get good at that, do we also get good at robots, or is there something fundamentally different?
This is a really interesting question. I think the difficulty in these kinds of physical systems is the variation, and this is why there are going to be probably humans and plants that are trying to be lights out for 30 years, even if most of the stuff is automated in 10, because there are transients, startup shutdown, things break, like stuff happens in a complex physical system, and when stuff happens, if you haven't seen enough of it, you can't automatically fix it. You need, a human to kind of be involved, or some other, agent that can work in a different way from the main line. And I would just say, like, flying has fewer sources of variation than, operating on the ground. And, and of course, that's a very general statement, and there's complex environments that I've never been in because I'm not an ex-military person, but I think in terms of controls, we've had automated flight control for decades versus truly automated terrain independent vehicles that can kind of navigate the physical world. And so I think that getting autonomy in the drone space, the work is going to be in the kind of orchestration of the, what you want the drones to do and how you want them to behave in battlefield conditions and how you want them to act when something doesn't work out. So how are they self-healing networks and that sort of thing? All of that is going to matter. It'll be helpful to have that in the ground-based stuff, but you're also going to have, a lot of the data that I was talking about before collected about the environments that ground-based things would operate in before they're going to be as robust as things that operate in the air.
Shoot another one my way.
So when do humans build the first lights out plant? And I mean like a manufacturing plant that literally there's no humans necessary to operate it, maintain it. It just runs.
One funny thing is we say lights out, and then I've had some people ask, like, why would we turn the lights out? We're not actually going to turn the lights out. Lights are quite useful for robots to be able to perceive the world. But it's I used my like AWS customer card to get a tour of the Gen 12 plant in Shreveport, Amazon's Gen 12. Have you seen that one?
No, not yet.
Try to work your way in, because it's everything we had on the design table in 2020 when COVID hit. Amazon finally built it, and I mean 25% productivity improvement, 25% speed improvement. And it's funny because when we did that analysis and we automated, we said, what's going to be left? We're like, it's mostly going to be people pushing carts, like handling these kind of secondary material flows, right? And sure enough, as soon as I walked in the building, the first thing I saw was someone pushing a cart full of totes, right? And I'm like, wow, like we were right. We projected into the future properly. I want to go tour the Lego plant because like the world just fills up with Legos and crayons. I feel like those are almost fully automated already. Coffee processing seems to like just show up at Starbucks with. So, I think there's more that is like high automated than people realize. But yeah, the connections, the next connections are some of that like ground level material movement, the exception handling paths and the replenishment paths, right?
Yeah.
And so, we're working with a big manufacturer right now on handling a bunch of those replenishment tasks. So when those start to come out, and then the transportation, right? The load and unload of the truck and the truck itself being automated. I actually think like for a number of industries, bottling or other things where like it's really been this complicated machines that really automate everything, we might not be, and with AI driven and statistical process control, the computers are driving a lot of it. Like really once we get the secondary material flows handled, which is what Cobot's heavily focused on, and then the autonomous load and unload and vehicle movement, we're not that far. So 10 years, 7 years, 12, something in that window.
All right. I give you a very specific question, though, about lights, like truly lights out, no humans anywhere around it. You really think 10 years?
I think for some very dedicated manufacturing capabilities, I think it can be completely inputs in and outputs out autonomously. I do.
And machines maintaining the machines?
So you mean no technicians ever coming in the building?
No technicians, no maintenance people?
Yeah, that's further out. That's
okay.
That's a good 20, 30 years.
All right. We agree as always.
Yeah. Okay, next question for you. You think a lot about, bottlenecks and where things are coming. Obviously, we're in this AI explosion. What's the bottleneck you're thinking about that maybe everyone's talking about data centers and energy, but is there another bottleneck you're thinking that people might be missing?
Well, I don't think they're missing it, but I think it's a hard one, and that is it's data. Like the data for physics models and for any kind of physical AI is not in the corpus of the web. And I'm talking about like milli and microsecond, frequency data. That kind of data is what it's going to take to actuate in really precise environments in the physical world. It's why an LLM can't drive your car. And we've spent, now almost 2 decades collecting enough data and labeling that data in order to be able to train these models that can operate a vehicle in the physical world. And this is gonna be true in every single instantiation of physical AI. We are not going to be able to use the compressed data that humans have observed and recorded in tokens on the web, in images, video, and and text as the basis for physics-based models. It's just there's too much other information that's going to be necessary, and I think it's going to be a big bottleneck. And a different way of framing that is that you might ask, which is sort of like what is physical AI going to look like in 10 years? This is a question you and I were talking about over email, and I actually think it's very hard to predict for sure. I think these, at an abstract level, these things that I've kept talking about, sort of flexibility and precision, robustness, speed, and cost. Those are the elements of the robots that we'll build in the future that are going to be really important. But how those elements sort of turn out, how each of those vectors looks for different applications, is going to be highly dependent on the data that we're going to collect in the next 10 years. So I think it's really hard to predict what the total ecosystem of physical AI is going to look like. What I know is going to happen is we're going to collect a lot more sensing and actuating data in the real world and in specific applications. And there'll be, a lot of that data will be proprietary for the people that work in those spaces. And that'll allow us to build both more atomized, things that can come together in manufacturing swarms or transportation swarms to do complex tasks with great orchestration that might be really hard for us to predict today. You are such a great software architect, and you probably don't write that much code alone these days. Like I'm not sure anybody does, but how are you thinking about if people that watch this have are young people who maybe just graduated with a computer science degree or graduated a few years ago, how is that skill going to be useful or not in the world that Cobot is helping to create?
Yeah, I think it is a very dynamic time. I think it's a very dynamic time for young people, right? I have a 17-year-old and a 15-year-old, and so I'm thinking about this like other parents as well, right? I think I think what's going to happen is the distance between our idea and being able to realize that idea in the world is going to get shorter and shorter. And so, for the Jeff Bezoses of the world, right, who are producing lots and lots of ideas, the speed between those ideas and making them happen is going to get less and less. And so I think it's important for young people to think about, like, be creators, right? And the creation tools can be music, they can be videos. The AI is giving us kind of great creation generation tools. Some of that can be code, some of that can be other things, but really kind of how do we inspire young people to create and to kind of get excited about these creation tools? I think with social media and things, we created this consumption, right? We created a consumption economy. We created this information consumption, just consuming all the time. The value is accreting to people who create or people who do, and so those creation tools are getting better and better. And so I'm encouraging young people to use AI, to think, and I get a little frustrated that schools have, been a little bit discouraging people to create with that. It's like, how do I create the poem I always wanted to write, right? By partnering with AI versus, trying to get it out of my own brain entirely, right? And I think, that kind of creation is very exciting, and the tools are only going to get more powerful, and that gap is only going to get smaller and smaller. So, entrepreneurship, taking ideas, creating, I think is going to be, that energy, that threshold of like, hey, I have the song I want to write, right? And then it's just, do you really have the activation energy to get over it? Well, now the tools are there and the energy you need to do it, and so just getting in that creative loop is the thing I encourage people to do.
It's awesome. It's awesome. It's good to see you, Brad.
Yeah, this was awesome. Thank you so much.